Question 5. A student says that the red triangle shown in the diagram below is a 120-degree clockwise rotation of the blue triangle about the origin. So this blue triangle has been rotated 120 degrees as shown here. So we have to check whether the statement given by the student is correct or otherwise. So let us see what happens if I rotate this triangle, though I am rotating counterclockwise, but it's okay. This triangle sits on top of the blue triangle. So there is a rotation, that is true, but whether it is 120 degrees or it is otherwise. In order to find this, how to measure the angle of rotation? The angle of rotation between the pre-image and the image should be measured between the corresponding vertices. So in this case, we have to measure the angle between the two segments, which are these two blue lines. It should not be measured between the solid blue line and the dotted black line. It should not be, which is as given is 120, whereas it should be the angle between the two solid blue segments, and these two segments are connecting the corresponding vertices of the red and the blue triangle to the point of center of rotation. So how we are going to find the angle of these between these two lines? So this is what we can do here. The angle we can find, the we can see the coordinate of the vertex of the red triangle connecting the center is 3 comma 2. So and the center is at the origin, so this is 0 0, and the point, the coordinate of the blue triangle, the vertex which is connecting to the center of rotation is we can see 1 2, so this is negative 2 and positive 3. So now we can find the slope of the two segments between the center of rotation. So in this line, the slope of this line is going to be, let us say, slope m, and that is rise is 2 and run is 3. Likewise, the slope of this line is going to be, and I'm going to call this, if it is a perpendicular line, then m perpendicular is 3 over negative 2. And if the two slopes are reciprocal opposite, then the two segments are perpendicular, and I can see it here, the two slopes given. So I'm going to, let me change the color to have a better. So now the slope of the one segment is given, so the m times m, the slope of the perpendicular line, if you multiply the two slopes, and if your answer, the product of the two slope is negative 1, then the two segments are perpendicular, and we can see that the slope, the product of these two slope is -1. So these two lines, the two segments, the blue segments connecting the two corresponding vertices of the red and the blue triangle, they are perpendicular to each other. So the angle between them is 90 degrees. So the angle between them is 90 degrees. So that uh, so the answer is going to be that the two triangles, the rotation is a 90 degree, not as mentioned by the student that it is 120 degrees. Let us do it again. Let us do this. So if I rotate this, and the angle of rotation, you can see it is 90 degree, and the response is going to be as written here. The corresponding vertices of the two right triangles must be used to measure the angular rotation. The angle measurement given is between two vertices of the red and the blue triangle, which are not corresponding vertices. You see that this one and this one, which is not corresponding to each other. The angle of rotation between the two corresponding vertices of the triangle is 90 degree, because the slope of the two blue segments are reciprocal opposite. The red triangle is 90 degree rotation of the blue triangle clockwise. So we can see that this is 90 degree because the angle between the two is 90 degree. I hope you understand the question and its visual demonstration.